Hey, this is Mr. Aiden from MrAiden.com, and this is the 2021 AP Calculus AB free response question number 5. So let's get to this problem. It is a differential. Ding, 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 ding. It comes up that we are going to be doing a differential equation on this one. I love differential equations, so let's take a look at what we got here. You can see they gave us a function, and y equals f of x, and the curve is given by the equation 2y squared minus 6 equals y sine of x, and this is all for y is greater than 0, and they want to show the derivative of this. So we have to do implicit differentiation. So 2y squared minus 6 equals y sine of x. So let's do a little bit of implicit differentiation. So we're going to take the derivative of 2y squared, and we get 4y, and don't forget we need dy over dx. Minus 6 is 0, any constant is 0. And now we have to use the product rule. So the derivative of y is dy over dx times sine of x plus y times cosine of x, because the derivative of sine of x is cosine of x. So now we want to get our dy over dx's on the same side. So we have 4y dy over dx minus sine of x dy over dx is equal to y cosine of x. Okay, and now we are going to factor out the dy over dx. So we have dy over dx times 4y minus sine of x equals y cosine of x, and now we are just going to divide dy over dx equals y cosine of x over 4y minus sine of x, and that is exactly what they wanted us to demonstrate. So, quota rut demonstrandum, we were able to figure that out. So let's take a look at B. B is asking us to write an equation for the tangent line to this curve, and we have our x point and we have our y point right here, which is really nice. We just have to find our slope. So dy over dx, and we knew that dy over dx, that slope is right here. That's y cosine of x over, let's make sure we get it right, y cosine of x over 4y minus sine of x. So 4y minus sine of x. And now we're going to plug in our points. So our root 3 is our y value times cosine of 0 over 4 times root 3 minus sine of 0, not sine of x, but sine of 0. And so keep in mind my unit circle. Okay, unit circle is really helpful to know on each one of these axes. So at 0, your cosine it's all x values, so all cosine. So that's going to be 1. Your y value, your sine, is equal to 0. So that's our cosine. Cosine of 0 is 1. This is our sine of 0 is 0. So we come back to our slope, dy over dx, and we have root 3 times cosine of 0, that's 1. So we have root 3 on our numerator. And we have 4 times root 3 minus sine of 0 is 0. So we have 4 root 3. So our slope is 1/4 because the root 3's cancel out. Now we're going to finish with our tangent line equation. So our tangent line equation is going to be y minus our y value of root 3 equals our slope, 1/4, and x minus our x value, which was 0. And here is my equation. Y minus root 3 equals 1/4 x, or you could even call this y equals 1/4 x plus root 3. And there is your equation to your line. That is part B. Part C is we're going to find the coordinates of the point where the line tangent to the curve is horizontal. And so what we're trying to find here is we're trying to find a kind of a relative min or max or something like that. We're going to set our slope. Our slope is going to be equal to 0. So because it is horizontal. So that means my dy over dx is going to be equal to 0. And remember what my dy over dx was. It was y cosine of x over 4y minus sine of x, which means we know this numerator, y cosine of x, is going to be equal to 0. So ask yourselves, where is the cosine equal to 0? So we think back to our unit circle here. Where is, and remember cosine is your x values, so where will your x values equal 0? Well, up here at 90 degrees, which is pi over 2, and down here at 3 pi over 2, your x values, it's all y. It's either positive 1 or negative 1. There's nothing in the x. So that is where you're going to be equal to 0. That's where cosine is going to be equal to 0. And so take a look at our limitations, though. Our limitations are we're going from 0 to pi, so we're in the first two quadrants, which means x has to be pi over 2, not the 3 pi over 2. So now, how do we find out what the y value is going to be? Well, let's go back to the original equation. Okay, so let's take a look at this original equation up here. So we have 2y squared minus 6 equals y sine of what? We're going to be sine of pi over 2. So what is sine? What is our y values of pi over 2? That's all sine of pi over 2 is equal to positive 1. So that means we have 2y squared minus 6 is equal to y. 2y squared minus 6 is equal to y. Which means we can kind of rearrange this and get 2y squared minus y minus 6 is equal to 0. We have a little quadratic. We just have to do our little quadratic right here. We have 2y times y. That equals our y squared. And we're going to get plus 3 and negative 2. Plus 3 and negative 2. Which means y could be equal to negative 3 halves, or y could be equal to 2. Now, what do I know? Y has to be greater than 0. So that means y is going to be equal to 2. We're starting to put together all the pieces to this little puzzle right now. Okay, so what do I know? What do I know? I know x is going to be equal to pi over 2 when y is going to be equal to 2. Okay, these are the coordinates. These are the coordinates. Now, we want to know whether this is, sorry, those are our coordinates. We solved our problem. I'm going on the part D too quick. Okay, so you can see how we had to find out where the line tangent to the curve was horizontal, which meant I need to find out where the slope was equal to 0. I took a look at that numerator right there. Then I plugged in that x value into my original equation to find out where the y value was. And you can see part D says determine whether our point in part C is a relative min, max, or neither. And let's think about what this point was. It was pi over 2 and y was equal to 2. And so this is my my point. And I'm going to kind of take a look at this a little bit different. I'm going to take a look kind of vertically, y is equal to 2. And so I want to take a look at some points, and it's kind of like first derivative test. I got to figure out whether it's a relative min or max. And so let's take a look at a point where x is equal to 0, and maybe a point where x is equal to pi, because we can know we can go from 0 to pi. Now, if we plug this in this original equation right here, when we have sine of 0, that's 0. So that's where 2y squared minus 6 is equal to 0. If we do a little bit of algebra, we have 2y squared is equal to 6, y squared is equal to 3, y is equal to root 3. Okay, it's got to be plus, it's got to be positive. So y is equal to positive root 3 when we are right here. And we know at pi, sine of pi is equal to 0 as well, so which means we're back to y equals positive root 3. Now let's think about this logically. Positive root 3, is that kind of bigger or smaller than 2? Well, we know root 4 is bigger, so that means this guy's a little bit smaller. Okay, which means my line is going up from a lower point up to this maximum of 2, back down to root 3 over here, which means this bad boy up here is going to be a relative max, because my point at 0 was at positive root 3. At pi, we're back at positive root 3. In this middle point, we are up at positive 2, which is a relative max. That's your amplitude right there. And that is question number 5 on the 2021 AP Calculus exam. I hope that helped. This was Mr. Aiden of MrAiden.com.